All right, so we're looking at these position versus time graphs, and obviously we know that our position is, our position is over here on our y-axis. It is going to always be on the left, and then our x-axis is always going to be time. You always have to include the units for both of them. But if we don't even have the specific numbers, or we don't even have the units listed, which isn't official, like that's not the way you want to do a graph, but if we have something that looks like this, we can look at this and we can definitely still know a bunch of information. So if I'm looking at this graph, there are a few places where we're looking at a positive value. So it's showing something that's moving like up, north, right, east, or forward. So give me the line segment. So we have A, B, C, D, E, and F. Give me the line segment where we have a positive value, where it's showing positive. What do you think, Audrey?
B.
Okay, I definitely like B. What else? Cole?
C.
Not C necessarily.
D.
D. So B and D are both pointing upwards, meaning a positive slope, meaning a positive velocity, and so that means it's dealing with a positive displacement. We know that positive displacement means up, right, north, east, or forward. Okay? Now between B and D, which one is going at a faster speed or velocity? And how do you know? What do you think, Charlie?
D, because the line is steeper.
Good, it's steeper, right? So that's all you're looking for. Just like with density, whichever line was steepest, that's the one you go with. All right, what about, which segment is showing a negative velocity or showing that negative direction, Kate?
F.
All right, and how do you know that?
Because it's slope going down.
That's all it is, right? You just recognize that it's going down. Where do you see no motion, or it's stationary, or zero slope, or zero velocity, all meaning the same thing? Where do you see that taking place? Will, do you see one?
A.
All right, why do you say A?
Flat. With no motion.
Just remember that flat line. Like if you look at an EKG monitor and there's a flat line, just like you see here, then that means that there is no heartbeat, meaning that that person is no longer with us and they cannot move around, they can't change position, right? So that's how we said to remember that. Where else do you see this happening? Let's see, Dylan, where else do you see a flat line area for no motion?
Flat line is also on E.
I like it, definitely on E. There's one more, Selena?
A.
Oh, we already had A, so we had A and E. Which one are we missing? Good. C looks really good. Okay? So that's basically my only other question. Do you see any of these segments that are showing a changing velocity or speed? Do any of these show a changing? So like, is this one showing a changing, or is this one showing a changing? Do we see that on any of these? Austin's saying no. Why not, Austin?
Because the lines, they're not curved.
Very good. The lines are all straight. Good. All right, so let's go. We're going to actually skip that one because we basically did that yesterday. Looking at this graph, give me a few ways that you could describe this object's motion, whether it's a car or a ball or a person. Like, we don't really know that, but for the motion itself, give me something, maybe like for the first 5 seconds. What do you see happening? What do you see going on? Caitlin, what do you see? For the first 5 seconds, give me a way to describe that motion.
Increasing.
It is increasing, and because it's a positive slope, right? What else do we know? Dylan, what do you think?
It's like going up.
Okay.
And it's not at a constant rate until it starts going into the 6.
Okay, so do you see that you're saying it's not a constant rate, so you're saying it's changing? Do you see this line being curved?
No, but it's it's going up, and that's a change in angle.
Okay, we're allowed to change the angle, but if it's a totally straight line, then that means that it is a constant. So this is like cruise control.
Oh,
You
so
see the straight line,
so it is constant.
it is.
My
If,
brain's just like, that's not straight.
right,
It's
so a straight line means nice and steady, right? If this was curved upwards, it would still be positive because it's up, but the curve means that it would be changing. So this is showing a constant. Good, and so then what happens at 5 seconds? What goes on there, Michaela? Yeah, it comes to a stop, right, because you see that flat line. So here's the way they describe it on slide number, 23. It says, this graph is showing a constant velocity for the first 5 seconds, and they actually calculated that. They, you can find the slope, and so they found the slope between 0 and 5 meters, and 0 and 1 second is 5/1. And so they said that that's a slope of 5 meters per, or a slope of 5, so that's basically a velocity of 5 meters per second, and it's constant, and it's moving in the positive direction. And then it says it abruptly stops and comes to a rest at 5 seconds for 5 more seconds. So basically everything you guys said. So really good. All right, our final one, and this is where we pick up, so we have these 4 lines, all right? So which line is showing the slowest motion? Let's see, Cheyenne, what do you think? Which one? Okay, so why is A, why did you pick A? It's not moving, so there's no motion at all. So if I say between the things that are moving, so if we eliminate A, which one would then be the slowest? D, good, so you recognize 2 really important things there, that's great. All right, which 2 lines do you think have about the same speed or velocity? Some of you geometry people, this might. Rory, what do you think?
Easy.
Why do you say that?
Because they're both parallel and
If they're parallel, then they're gonna have the same slope, and if they have the same slope, then they're gonna have the same velocity or speed. And we don't know if this is velocity or speed, because it's just saying position. If it told us that this was distance, then we would know it's speed for sure. If it said displacement, then we would know that this is representing velocity, but we don't know that exactly, so that's why I keep saying speed or velocity. Yes?
A and B will cross eventually,
They sure would, yeah, they would.
because
All right.
A is going completely straight and B is going upwards, so it would eventually go like that
At some point, you're right.
at some point.
Do you see any motion that is constant here? Do we see any constant motion? What do you think, Maddie? Okay. Anything else? Emily? Why do you say all of them? They're all perfectly straight lines. So, yeah, all of them are showing a straight line, meaning that constant movement, or constant motion. Like, they're all on cruise control, right? And even A, there's no motion at all, but it's still a straight line, so. Okay? So, we're gonna go ahead and let's stop there, because then we start into our velocity graphs, and the velocity graphs, we haven't gotten to acceleration yet, so we are not ready.